Okay, here's our question B from this paper, and so now I've got the same situation for another hockey team, and the mean number of goals that they score per 60-minute game is 0.8. So we've been asked to calculate the probability that in 2 different games they score fewer than 3 goals in each game. So this is still going to be a Poisson problem, and so I've got our rate of 0.8, and so let's look for the probability that they score fewer than 3 goals in one game. So we're just looking at the probability that x is less than or equal to 2. And so we'll use our calculator for this. This is reasonably straightforward for us. So we'll go to menu and distributions and Poisson, and we'll do PCD because we're doing everything up to and including 2. So 2, and our rate is 0.8, and there's our probability, 0.9526 we'll say. So let's write that down. P equals 0.9526. Now if we're looking for the probability of this happening in 2 consecutive games, so the probability that x is less than or equal to 2 in any 2 games, then that's just going to be the probability that we get it in one game times the probability that we get it in another game, and that gives us 0.9074. Now the question's asked us to comment on assumptions that we've made, and probably the big assumption here is that the scores of each game is independent. So game scores are independent of each other. And the reason why we have to make this assumption is because this is not always the case. Of course, often teams play better following a game where they've scored well, as opposed to a game where they've scored poorly that's often followed up by another poor score. So yeah, we'll just note down that assumption there. Okay, let's look at part 2. So using the appropriate distribution, find the probability that the team will score at least 3 goals in at least 2 of the next 5 different 60-minute games. So we've kind of been given a couple of things here. This is partly Poisson but partly binomial, so let's just see what happens here. So first of all, we'll deal with the bit at least 3 goals. So that's probability that x is bigger than or equal to 3, and so that's going to be 1 minus the probability that x is smaller than or equal to 2. Now we worked that out in our last question, and it came out as 0.9526, and so the probability of getting more than 3 is 0.0474. Alright, now that's the Poisson part, but now because we're looking at 2 out of 5 games, that's becoming a binomial problem. So we'll just write down here binomial, just to show that we're going to work with binomial here, and at n is 5 because we're looking at the next 5 games, and it's saying that x has to be at least 2, so bigger than or equal to 2, and our probability is what we just worked out using Poisson, is 0.0474. And so what we're working out is the probability that we win more than 2 games out of the next 5. So that's going to be the probability of 1, well that's going to be 1 minus the probability that x is less than or equal to 1. So in other words, this one here is looking for 2 and above, so on. So if we take away 0 and 1, then what we're left with is the probability we want. And so we're going to need our calculator for this again. So this time we're wanting binomial. So distributions, binomial, BCD, and our x is going to be 2 for this one. Number of trials is 5, and our probability is 0.0474, and we'll just double check that we've got that right. Our x is supposed to be 1 actually. Okay, there we go. So 0.9796. So I'll put that into here, 0.9796, and so that gives us a probability of 0.0204. Now once again, it's asked us to identify parameters and state any assumptions. Well, we've done our parameters, that's all part of our working, and so now we need to state our assumptions. And so our assumptions are that the probability of scoring 3 goals or more in any game is fixed. Now why do we need to make that assumption? That's because for the binomial distribution, that it only works when that probability is fixed. So that's one probability we've got, and we're also still assuming that any game outcome does not affect the probability of any other outcome. And so we're basically saying that it's independent there, because both Poisson and binomial require independence. Okay, and so that's question B.